Hello everyone, welcome to the channel The World of Maths. Today we came up with a new topic, rational and irrational numbers as terminating and non-terminating decimal expansion form. Now you will be thinking what is terminating and non-terminating, we are not understanding. Okay, so we will understand. Before that, what is the definition of rational number? Our old definition of rational number, that is a number in the form p by q, where p and q are integers and q is not equal to 0, is known as a rational number. So if p by q is a rational number where q is not equal to 0, then two things can happen. First is remainder becomes 0, and second thing can happen, that is remainder never becomes 0. Okay, so let us understand with example. Remainder becomes 0 if we take the fraction 1 by 2, which is a rational number. So when we divide 1 by 2, we get 0.5, a decimal number. So it is a terminating decimal expansion. Terminating is known as, this decimal form is known as terminating decimal expansion. Now let us see this side. Remainder never becomes 0. Suppose 1 by 3. So if you divide, we get 3 dots. Give only 3 dots. Okay. So here remainder will never become 0. We are getting repeating digits. Okay. Another example, if you take 4 by 5, so 0.8. Okay. So this will be here, not this side, because here remainder is 0. Another example, that is, we can write here 4 by 5. That is 0.8. It is also a terminating decimal expansion, because when we divide 4 by 5, we get remainder as 0. For this, any other example, 1 by 7. If you divide 1 by 7, what is the repeating block? Can you tell me? What is the repeating block? 0.142857 and dot. Okay, so again this repeating digits, block of digits, repeating string of digits will be repeated here. This string of digits will be repeated. Again it will start from 142857. Okay, so these here remainder is never becoming 0. So this type of decimal expansions are known as non-terminating, repeating, because digits are repeating. So repeating or recurring decimal expansion, right? So non-terminating because it is not terminating, not ending, and repeating or recurring because digits are repeating. So decimal expansion. So whenever the decimal expansions are given, by observing the decimal expansion, we can say these are the rational numbers or irrational numbers. These decimal expansions are for rational or irrational numbers, right? So we have understood what is a rational number. Rational number can be in the two forms. Okay, one is remainder, when remainder is becoming 0, when we are dividing p by q, remainder is becoming 0 and we are getting terminating decimal expansion. And when the remainder is not 0, then we are getting non-terminating, repeating or recurring decimal expansion. Then what about irrational numbers? What are irrational numbers? Irrational numbers are non-terminating, non-repeating decimal expansion. Let us take one example for irrational numbers. Irrational numbers. Just like one example, 0.14 144, 1,444, and so on. So here you can see no digits are repeating. There is no repeating block of digits. Okay, so these type of numbers are known as irrational numbers. These are known as non-terminating, non-terminating, non-repeating, non-repeating decimal expansion. So let us differentiate rational and irrational numbers by one more example. Can you tell me that whether pi is rational or irrational? Because value of pi is 22/7 or 3.14. So it is looking like pi is a rational number. But whether actually pi is a rational number? No, pi is not a rational number, because when you divide this 22/7, you will not get exactly 3.14. We have taken this, we consider the value of pi approximately 3.14. But 22/7, when you divide this, you get something like this, 3.14, then 159, then a big number we get, where there is no repeating block of digits or no repeating string of digits. Okay, so we know from the definition of irrational numbers that no digits are repeating, there is no block of digits repeating in the irrational number. Therefore 20 pi is not a rational number, or pi is irrational. Pi is irrational. Okay.